Hello and welcome to this video. My name is Ranat Ishmuhamedov. I'm a lead product manager at Alteryx Data Connectors team. With this video, I'd like to demonstrate how Alteryx users can leverage AWS Trusted Identity Propagation authentication method that Alteryx Data Connectors team released in 2042 release. This authentication method is a very powerful authentication method that can be leveraged to streamline cross-cloud access control when you essentially are able to propagate your identities from external IDPs, let's say Azure AD or Okta, Ping Federate, and others, into AWS Identity Center without assuming any new roles, and then basically propagate that identity context and in order to get a set of temporary credentials from to access your AWS resources such as S3 buckets or Redshift. As part of this video, I will walk you through the end-to-end configuration required to set up your Azure AD environment with AWS Identity Center. We'll go ahead and configure all the respective AWS entities and resources such as policies, roles, and user. We'll collect all the required inputs for us to create a new AWS Identity Center application that will facilitate this authentication mechanism, as well as we'll finally go ahead and create a new S3 access grants instance, which will be issuing S3 access grants, as well as create a new S3 bucket, which we'll be accessing using the identity propagated from Azure AD. Without any further ado, let's take a look at how this works and what required steps we'll need to complete. A small note here, during the course of this video, we'll be using a set of developer tools. So the expectation is that you are familiar with some of the external tools or developer specific tools such as Postman, or have some basic Python developer experience so that you're able to operate with some of the basic commands in those two applications. So let's take a look at how this works. I will start with sharing my screen, and here is the high-level overview of the configuration process we'll be doing today. So we'll first of all go ahead and configure a new Azure AD application in our Azure AD environment and collect the required inputs. We'll then move on and register a new trusted token issuer in AWS. This step will ensure that the Azure AD issued tokens are recognized and are trusted by AWS Identity Center. Then we'll create a new AWS policy allowing AWS users to exchange Azure AD issued tokens for the identity context against IDC. We'll create a new IAM user who will have required permissions to perform an action called create token with IAM, which basically would allow us to get a set of temporary credentials. We'll generate a new set of credentials for the user, as well as create a new IAM role that will grant our users access to requested services and set the trust relationship. And those respective services would be S3 as well as Redshift access. And at the end, we'll create a new AWS S3 bucket that we'll be reading the data from. We'll also create a new AWS Redshift instance as part of this tutorial and configure respective services. And we'll create a S3 access grants instance and assign it to the bucket to grant the role that we created in the previous tab with rights to access the grant instance. So let's move on through the configuration, start with configuring our Azure AD environment and collect required inputs. For this purpose, I'm going to navigate to my Azure AD environment. I'll go to the app registrations, and here I have my Azure AD configuration. The step number one, I'm going to register a resource application in my Azure AD, and this resource application will represent an API which will be exposing via the JOT tokens and granting access to from our client application. So for this purpose, I'm going to register a new application. I'll call this application TIP, which stands for Trusted Identity Propagation resource app. I'll set the resource app to only be available or provide authentication for the accounts in this organization directory, and I go ahead and create register. That's pretty much everything I need to configure in this application. I also, one more step, I need to go to the application, register, and expose its API. For this purpose, I go to the overview, I navigate to the expose an API tab here, click the application ID. I'm fine with this default value here. And I need to assign the application with some sort of scope value. So I'll call it TIP. That will be my scope. And then I'll grant both admins as well as users an ability to consent to use this application. I will provide some descriptive name to the scope, calling it TIP scope, and user display consent name will be TIP scope as well. And I leave the state as enabled. So I want to keep this TIP scope, providing TIP scope access. And I'll leave the state as enabled because I want this scope to be enabled by the application. Great. Now that I have configured my application expose the scope, everything I need to do, I just need to do a few things. I need to copy this scope value. Now, if I go back to my code editor, just start noting down the values. So this will be my Azure AD configuration. So this will be my resource application. And here I have the scope that I have configured. And one more item I need to collect from my Azure AD application is the actual application ID, or just the name of the application would be fine. Okay. So this will be the name of my resource application and the scope of my resource application. Wonderful. The second step I need to do, I need to go ahead and register yet another application here, which, unlike the first application that I called TIP resource app here, will be called the TIP client application. So essentially, this client application will serve as my OAuth client that will be exposed in an API, and that API will be represented by the resource application that we configured in previous step. I need to provide a few additional inputs. I'll keep the supported account types to be organization accounts within this organization directory. I'll select a platform. I'll give the platform was an input, and I'll set the HTTP localhost as my redirect URI, and I'll probably set the port to be 8000. It's important to actually assign a port value that you'll be using as part of this authentication flow. So I'll keep the redirect URI to be HTTP localhost 8000. I click register. And this value will be known as my, so I'll first of all create a client application details here, and this will be my redirect URI. We'll need all these values at a later stage of configuration. The next thing I need to do, I need to copy the client ID of my client application. So this will be my client ID. And I need to grant this application with permissions to access our API. So therefore, I navigate to the API permissions. I click on this Add Permission tab. I navigate to the API my organization uses, and here I have my. I need to locate the application I have just created, which will be my resource application. So it's TIP resource. I set the permission to be delegate permission type, and I then add the scope that we configured for this resource application. Great, so now I have my permissions assigned. I also am required to grant the admin consent to expose this permissions to all the users. The next step I need to do, This step is optional. It really depends on how your IT team or user and IT admin decide to configure the trust between your Azure AD as well as your Identity Center trusted token e-share configuration. But usually my preference is to use email as a unique identifier of an identity. In some cases, you may want to use a UPN claim of the JOT token that gets propagated into your Identity Center instance. And therefore, this step could be optional for your case, but I want to map my user identities between Azure AD as well as and AWS Identity Center via the email claim. To make sure that actually my tokens always contain the email claim, for the user, I need to navigate to my client application and click on this optional claim, navigate to token configuration, click add optional claim, and here I need to select the type of token that I want to use. For this purpose, please note that the Alteryx Designer only supports access token based token mapping. So you need to make sure that your access token that you assign this this email claim to the access token specifically. So I click add, and I need to turn on the graph APIs in order to get this claim. As you can see, I also need to once again grant an admin consent to the email claim here, and additionally, I would need to navigate to my application, locate my TEEP resource application, go to token configuration, and here navigate to e-access tokens and make sure that okay, I'll probably need to disable this and do it again. And my resource application, which is my API, needs to have the email claim configured as well. Yeah, I need to grant admin consent in here as well. Great. Now we have our client and resource applications configured. What I need to do now, I need to collect a few additional inputs, and those additional inputs would be required for me to, well, first of all, test that validate that my OAuth client actually grants issues the tokens for identities created in my Azure Active Directory, as well as there will be one important input that we will need in order to configure trust between our Identity Center instance as well and Azure AD. So the inputs I need for my authentication are the token endpoint as well as authorization endpoints. They're easily discoverable. To get those values, you navigate to your client application. There is an endpoint tab at the top of the screen. And here you can see that you have this V2 endpoints for V2 authorization and V2 token endpoints, which is go ahead and copy and save these values in here. Okay, and this value will be this code that we will be requesting from our client application. I think at this point in time, we have all the required inputs for us to be able to test that our Azure AD configuration works as intended. For this purpose, I'm going to navigate to my Postman, and here I'll create a new Azure AD OAuth Postman collection. I will not actually be performing the request, but I'll just be using it for authorization and authentication purposes. So I create a new authentication request, and I need to provide a set of required parameters. Well, first of all, you can see that I'm prompted to specify my callback URL, which is the redirect URL value that we collected in previous step. So I will go here and copy this and paste it in here. I then am prompted to specify the authorization and token URIs of my OAuth client, which will be this URI here and this URI, the token endpoint that we copied. from our client application. Then I'm prompted to specify the client ID of my application, and you can do so by just copying this client ID. It's important to note that this is an ID of our client application, not the resource. Optionally, you can also set a client for a client secret, but since my application is a public native, and it does not require client secrets. And finally, and this is the most important step here, we need to specify the scope of access. And here in the scope of access, we specify that we need these credentials to be from this applications. So this would be our scope, which is the API that we are requesting this client to issue access token for, as well as we'll be requesting additional scopes, OpenID and email. And these scopes are important for us to get the email claim propagated into the JOT token, resulting JOT token. Great. And obviously, this whole setup implies that you already have an Azure AD user created in your Azure Azure Active Directory or Entra ID. The user I'll be authenticating with will be my current user, which is essentially, I think this is the user I'll be using for test purposes. Yes, and the user has renatish@gmail.com email address. Wonderful. So it seems like we're all set. And what I can do now, I can click on this button, get new access token. I'll probably clear the cookies now, so to show what will happen once you click on this button. So as I click on get new access token, I get this external browser with tab where I am prompted to sign in with my Azure AD credentials. So specify my email, like the email address of my user. Okay, I'm prompted to provide the code that was sent to me by email here as part of our verification process. Okay, so this is the code that I just received in my email. Click sign in. And wonderful, as you can see here, Postman returns us the access token as well as ID token. The one that we're looking to use is the access token. So if I go ahead and copy my access token and go back to my browser and then go to a website called job.io, you probably are familiar with this website because it allows you to decrypt the JOT tokens you have. So you copy and paste your JOT token into this JWT tab. And here on the right-hand side, you right away see the actual values that are passed in via the JOT token. And the values we're interested in are the audience values. You can see this this value represents an API, or essentially an ID of the the resource application that we created. So if we navigate to our collection, we'll see that it perfectly matches those values. We can also see that we have the email claim that got propagated into the JOT token, which is very nice, which is exactly what we intended to see there. And one value that we want to obtain here is the issuer value. This value is the value of the issuer, essentially our Azure AD tenant that issued these tokens, and this value is important to us because we'll use it later. So I'll copy and Azure and save it here. Azure AD issuer. Okay, very good. So with this step, we completed the step number 1, which is configuring Azure AD environment and collecting required inputs. And I think at this point in time, we have already done this, so we can mark this as done. Let's proceed with the step number 2. And the step number 2 is registering a trusted token issuer in AWS Identity Center. For this purpose, we're going to navigate to the AWS console. And here is my AWS console page. And if I navigate to Identity Center, IAM Identity Center, I will see this view. Obviously, the expectation is that you have your identity center enabled in your organization account, and this is what we are planning to use here. Next, we're going to navigate to settings. Click on authentication tab, and here at the bottom screen we have trusted token issuers, which is where we need to register a trusted token issuer. To register a new trusted token issuer, we click on create token issuer, and here we are prompted to specify the issuer URL. As I mentioned earlier, the issuer URL is the URL of the issuer that is propagated via the JOT tokens. So we copy this URI and paste it in here. And then we need to provide a trusted token issuer name. In this case, it will be Azure Active Directory. And finally, we need to specify the token mapping attributes. Essentially, this is a definition of a rule that the Identity Center will use in order to map the identities propagated in JWT token from identity provider to the Identity Center mapping attribute. We'll stick to a default where we'll be essentially with this rule we're defining that the email claim of the JOT token that we received, right, propagates a unique identity of a user to an email attribute of a user in IDC, right? So it basically says, whenever you get a new JOT token, you need to make sure that the unique unique user identifier is actually propagated inside the email claim, and you map that, you validate that the value in that email claim is used in order to identify a user in IAM IDC. Great. So with this step, we complete our configuration and click Save. And I think we're pretty much done with this step as well. We registered a new trusted token issuer. So we click type Done. The next steps are important. We will need to create a new AWS policy allowing AWS users exchange Azure ID issued tokens for IDC credentials. So for this purpose, what I'm going to do, I'm going to navigate to IAM console in my AWS account. Right, I go to policies. And for the purposes of this video, I'm going to create a new policy, even though I already have a policy created. So just to show you what the policy definition looks like, the policy definition we'll be creating looks as following. Will be essentially allowing allowing access to perform SSO or upgrade token with IAM to research on all the resources to a specific role, right? So we can you can just pause this video and locate the exact policy or type in the policy definition in your policy view. What I'm going to do for the purposes of this demo, I'm going to create a new policy. I'll navigate to JSON tab here and provide this policy definition inside the policy editor. Otherwise, the visual definition looks as following. You need to basically navigate to the OIDC service, and then under the access level, you need to assign the create token with IAM permission. Great. I need to also provide a descriptive name to this policy. Let me see what the naming convention I'm using in this case. So I'll call this TEEP policy preview. Or let me call it example. Right, and I click create policy. Wonderful. Now we have a policy created. The next step for us is to creating new, we need to create a new IAM user who will be able to perform the create token IAM action by starting the user with a policy created above. Wonderful. So what we're going to do now, we're going to navigate. Just move this tab to the side. All right, we're looking to navigate to Users tab. And here I have a bunch of users created already. So what I'm going to do, I'm going to create a new user. I'll call it cheap user. I will click next. I will attach policies directly to user. And there's a policy that we just created. As you remember, it's called cheap policy example. Let's make sure this is a right policy definition. Yes, it is the right policy definition we want to attach to the user. So we click next. And we click create. So now that we have our new tip user that we have just created, we need to create a new set of credentials for this user. Just to recap, what we have done so far, we have defined a policy allowing the policy holder to perform create token with IAM action, and we created a new user who we have attributed this policy to. And now this user also needs to have a set of credentials for him to be able to perform that action, meaning create token with IAM, right? And in order to get a new set of credentials, we navigate to security credentials over here. We go to the access key and create a new access key. For the use case, we'll use application routing outside of AWS, which is essentially exactly what we're trying to do here. And we click next. We might want to provide some tagging. I'll skip the tagging step here. And what I need to do now is I need to copy the access key ID, right? So this will be my user, and this will be his access key ID, and the secret key here. Make sure to copy these values, as you can only see them once during the creation. Click done. Wonderful. Now our user has the respective permissions. Next thing we need to do, as per our guide here, we need to create a new IAM role that will grant users access to requested services and set trust relationships with the user. Okay, this will be the role that our user will be essentially assuming. So what we need to do for this purpose, we need to navigate to, once again, to our IAM console and go to roles. We can create a new role. I already have a role created here. I'll just put the configuration just to make sure that I do not miss anything. For the trusted entity type, I'll go ahead and create a custom trust policy here that I'll attribute to, I'll create a custom trust policy here and create a trust between this role and the user that will be using this role. For this purpose, I want to go to this other user that I created, and here is a trust policy I have already configured earlier. You can pause this video and copy the exact same configuration. But if you are familiar with trust policies in AWS, this trust policy basically tells the AWS that this AWS service or entity, which is basically the user, can perform STS assume role and STS context set context actions on the resource on this role. So I go ahead and copy this trust policy definition and paste it in here. So this is my custom trust policy. The only thing I need to update here is that obviously my user is not called, does not have this RN. Instead, my user, the one that I created, has a different one. So I need to go back to users here and locate the user that we created, which is this tip user, and navigate to the summary tab and copy the RN of the user that I'm assigning this permissions for. Okay. And yeah, the remaining configuration can stay the same. I click next. Next, I need to add this role with permissions, because the first step was for us to configure the trust between the role and the resource, which will be able to use this role. For the permissions tab, I need to create you can create a new access policy. I already created one myself. It's called S3 get. Let me locate it. It's called S3 get data access here. Okay, for some reason this policy is not available to me, which is interesting. Okay. Okay, let's do the following. For now, I'll set the S3 full access permissions to this role, but I'll revoke those permissions because I mean, obviously we do recognize the fact that this is like a too broad scope of access to permit to one single role. And finally, I need to specify the name of the role. And what I'm going to call it, I'll call it tprole. Right, review the configuration and create a new role here. Wonderful. So our role has been created. It's called tprole. And like I said, I do not want to grant this role the AWS full access, S3 full access permissions. So I'm going to remove this permissions for now. I'm going to add permissions and then create an inline policy. And I switched from visual to the JSON view. And here I need to copy this policy definition. Right, and you can once again pause the video and see which permissions this policy defines for the role. And next, then I click next, and I give a policy name. I'll just be very consistent here. I'll call it S3 get data access policy. I want to name it, and I click create policy. So now my role has been fully configured. It has required access rights that it basically exposes to the policy holder, to the role holder. Then I have the trust relationship configured between my user, who is entitled to perform create token with IAM permissions, and the actual role. And I also need to grant the access grants permissions to use this role as well. I think we're done here. The only remaining thing that I need to copy is basically the name of the role that we'd like to be using in this configuration. So therefore, I will just AWS configuration. Right. So I will go ahead and paste the name of the role RN. This will be the RN that I will need to use in further configuration. One step we have not documented here yet is something related to the identity center configuration. Let's complete this. So as you remember, what we have done so far, we navigate to IAM Identity Center. We have so far only created a new trusted token issuer, which is which creates a trust between our Azure AD tenant and our IDC. However, the intermediate step in IAM IDC is to have a customer managed application that will essentially be able to exchange Azure AD issued tokens for AWS Identity Center identity context as part of this authentication flow. To do this, we'll need to create this application. So we navigate to the application tab inside our Identity Center console. Click on Customer Managed. And I will go ahead and create a new application. I will set a preference to have an application I want to set up. I will set OAuth2 as a application type. Click next. I will provide this application with a name, so I'll call it Azure AD tip application. I hope we can use underscores here. Okay, we can. I will not require assignments to this application. And I will make this, I'll set this application to be not visible. Wonderful. Now we click next, and in the next step, we are prompted to specify the identity source or the trusted token issuer that, or token issuer that can be trusted by this application. For this purpose, I navigate to trusted token issuer. Here I have my Azure AD Azure Active Directory, trusted token issuer, which we configured earlier in this video. And I need to specify the audience claim. The audience claim is very important here because the audience claim represents an API, which basically represents, which is exposed by the JOT token or the JOT token holder has access to. And if I navigate back to my JOT token, I can just go to the audience here and just copy this entire value. And as you remember, this is essentially the API which this JOT token has been issued for. So I'll copy this value and paste it in here. I do not change any other configurations here, and I will now be prompted to specify the IAM role for this application, which has respective permissions. And as you remember, we have copied the IAM role the ARN of IAM role that we created. So I'll use this ARN AWS IAM role with tip. Okay, this is the ARN of the role that we created earlier and granted all the required permissions and access control. And if I click next, we can review configuration and click submit. And voila, everything has been configured. So this step was really important because this step basically creates this application that will allow our users to perform create token with IAM action, which essentially allows them to exchange Azure AD issue tokens for Identity Center issued tokens. And before we move on with the final step of configuration, we can navigate to the users. And as you remember, the user I'll be authenticating with, the one that creates existing Azure AD, is called brandonish@gmail.com. And if I navigate to here, I can locate this user, and you will see that remember the email attribute, which we used for token for identity mapping, has exactly the same value. So essentially what you can do, you can configure like a scheme provisioning from your Azure AD tenant into AWS IDC. So whenever you create a new user there in Azure AD, that identity will get propagated into AWS IDC. You'll make sure that you properly map the Azure AD attributes to the IDC attributes, so the email claim is always propagated as an email claim, so that the email attribute of the Azure or Entra ID user is always propagated as the email claim in AWS IDC. And yeah, then you can leverage this entire scenario yourself so that you can actually manage all the users from your Entra ID environment, assign them to groups and users, leverage groups and users here in IDC, and then perform this authentication flow in order to get your temporary scoped access credentials for S3 as well as Redshift services. Just a small note, a brief note from my end. Wonderful. Now that we have the application configured and we have most of these details available to us, what we need to do, we need to complete a few final steps. We will go ahead and create a new AWS S3 bucket, and we'll create a new S3 grants instance. And these steps are important for us to be able to access our S3 bucket using this authentication method. Let's start with creating a new S3 buckets. To do this, I'll navigate to the S3 console of my AWS environment. And I have a bucket here. Let me remove this bucket because I no longer need this. And I'll go ahead and create a new bucket. And I'll call this Azure tip bucket. I'll keep the remaining settings as their defaults. I will enable public access to this bucket so that I am able to access it from my public internet using secure credentials. I will, I'll not change any of this additional settings, so I'll just go ahead and create this bucket for now. Here's the bucket I created. I'm going to go ahead and add a file to this bucket. So I'll just upload this file in here, just for the sake of having some data in there. So the file that I have uploaded is called test.yxmd. Next step we need to create an access grant for our bucket. So here I have my, okay, I'll just go ahead and drop this. I need to register this access grant instance first and then delete the instance. Okay. This is a legacy S3 grant instance that I created earlier, so I'm going to drop the entire configuration so that we can start from the very beginning. So now I have no access grants in my Europe's EU Central 1 region. What I'm going to do, I'm going to click on Create S3 access grants instance here. I don't want to add IAM Identity Center instance in here. This type is optional because I want to leverage my organization access grants instance for this purpose. Then I click Next. I am now prompted to specify to register a new location, meaning new access bucket, new S3 bucket that I'll be using this S3 grants instance with. So I click on Browse. I locate our Azure T bucket instance that we created, and I choose a path. Then I need to specify the IAM role, which I would like to grant to this S3 grants instance, and the role that we'll be using is the one that we created earlier. It's called tip role, right? Because this role holds all the permissions for it to enable to allow issuing those credentials and exchanging those credentials. Then I'm prompted to specify the sub prefix, which is an optional step. I'll just do all. So this basically star means that this S3 grant is entitled to issue credentials for all the assets within the bucket. Then you can define which permission types you would like to perform in here. So you can either decide to only allow read or only allow write or allow both. And the IAM principle that we'll be using this role will be once again the tip role that has all the required permissions to perform these actions. So I click Next and I click Finish. As you can see now, my S3 bucket configuration has been completed. One step I need to, the final step I need to do, I need to connect this access grants instance with my identity center, right, for the configuration to work, so that this S3 grants instance trusts my identity center issued identities, and therefore I click on this add button here, and here I'll be prompted to specify the identity center IAM Identity Center ARN. So I navigate to IAM Identity Center. I go to my settings, and here I can copy the instance ARN of my Identity Center. Okay. and add IAM Identity Center. And now we have the S3 grants instance connected with our Identity Center. And this S3 grants instance is also configured to issue credentials for the specific bucket. Hello, everybody. With this video, we're going to continue the work we completed last time in our previous video, where we configured Azure AD environment to be a trusted token issuer and the trusted identity provider for our AWS instance, AWS Identity Center instance. And we then configured that AWS Identity Center to basically issue temporary credentials for our S3 buckets. In this video, we're going to move one step further when we would configure our Identity Center and AWS Identity Trusted Identity Propagation as an authentication method for Redshift. So let's take a look at how this works. I first of all go to my IAM console here, and the very first step I'm going to do is I'm going to create a new policy. I'll switch to JSON editor, and I have this policy already created here on my end. This are all the permissions that the policyholder will hold, and the policyholder will be the role which we will attribute this policy to. You can pause the video and take a look at all the permissions we are collecting here. Next, we're going to provide this policy with a descriptive name. So I'll call it AWS TIP Redshift policy. Oh, okay, there are some characters that are not allowed for the policy name. Great. Now that I'm done creating my policy, I just click Create Policy and have this policy created. Let's double check that this policy exists. I think it's called Redshift. Yeah, here is our policy we just created. Next step we're going to do, we're going to create a new role. And for this, we navigate to our roles console. We create a new role. We'll select the AWS service as a trusted entity type. We'll select the service type. This will be Redshift. We'll select the use case to be Redshift customizable. And next, we give this role some permissions, and our permissions will be the Redshift policy that we have just created. Should be somewhere here on our list of policies. Should probably refresh this for now. Yeah, and here is our policy. So we select this policy, click Next, provide role the name. I'll provide it with the name AWS TIP Redshift demo role. Great, and we create the role. Wonderful. Now we created our role for our Redshift instance to be able to communicate with our identity center in order to validate whether the identity provided in the JWT token or in the access token that we receive from Azure AD is a trustable identity that actually exists in our IDC user base and could be used for further validation. So now that we're done with creating the roles and policies, we're going to navigate to our Redshift console. Here is the Amazon Redshift. Nice. And now we're going to go to the IAM Identity Center connections here. And here I already have one application created. I'll create another application now. So I am clicking the Create Application button. Then I click Next. I need to provide this application with a descriptive name. This application will be called AWS TIP Redshift demo. And I'll give this application a thing. I am not allowed to use hyphens. I probably am Okay, I'll just call it AWS tip. Okay, it doesn't like some of the characters here. Let's see what we allowed to use. Okay, Redshift tip application demo. Lovely. For the connection with third-party attributes, we should keep the AWS IDC as a prefix for all the identities. And for the IAM role, for IAM Identity Center access, we should select the role that we created in the previous step, which is the AWS tip Redshift demo role. We do not need to enable the VQ V2 access for IAM Identity Center users. I am going to also select the Amazon S3 access grants as an option here, because our Redshift instance would need to have access to the S3 buckets as well, certain scenarios. And finally, I have my, I need to configure the trusted token issuer for this integration. And my trusted token issuer will be the trusted token issuer we configured in the previous step, in the previous video, when configuring the trusted identity propagation for the S3 scenario. So here I'm selecting the Azure AD tip demo, trusted token issuer, and once again, I'll need to specify the audience claim. To be honest with you, I do not quite remember from the top of my head the audience claim that we get there in the Azure AD token. So therefore, what I'm going to do, I'm going to sign in again, get the JOT token I received from Azure AD, go to jot.io, and decode the JOT token and get the audience claim value. Wonderful. So we are all set with this configuration, and we go ahead and create a new application. Now that this application has been created, we are good to go to create a new Redshift instance. So what I'm going to call this instance, I'll call it Alteryx. I'll set the minimum number of cores I need for my Redshift instance. I do not need to change the limits or anything. One thing to note here is that as part of this configuration, you need to make sure that you have a VPC security group configured that would allow specific inbound and inbound connections communicating with your Redshift instance. So here I have a rule which basically permits all the inbound connections into the Redshift instance. Otherwise, your Redshift instance will not be accessible from the public internet. I do not need to select any subnets or whatsoever. I think they're all selected, and I enable SSL for this instance. Next, I click next. I shall also select the name for my namespace in Redshift. I'll have my default database to be called dev. I do not want to customize my admin credentials. And I need to associate IAM role with my Redshift instance. And for that, I'll go to associate IAM roles. And once again, select the role that we created, because that role basically contains all the required attributes for the Redshift instance to communicate with AWS IDC. So now that this associated IAM role has been created, I want to enable IAM Identity Center connections for cluster. And I need to specify the application that will basically allow will allow our Redshift cluster to communicate with Identity Center and validate all the identities propagated by the JWT token. So here I select the Redshift tip application demo that we just set up. And I do not want to change any of those other default attributes. I click next. And I click create. Now we need to wait for our Redshift cluster to be created. This might take a few minutes. All right, now that our Redshift instance has been successfully created, We still need to do a few things. Well, first of all, we need to make sure that this instance is actually publicly available. So for this purpose, we're going to navigate to the Redshift instance and go to publicly accessible and turn on publicly accessible, so that this basically makes our Redshift instance accessible from the outside of the AWS VNet. Another thing we need to do, we need to navigate to our IAM Identity Center, go to Redshift, tip app with demo that we created earlier, go to add assign users, and we need to locate the user that we would like to assign to this application so that these users' identity could be propagated to our Redshift instance. So we select the Redshift user, go ahead and assign the user. Sweet. I think at this point in time, we are all set. And what we need to do now is to try and authenticate. For this purpose, I'm going to get a new access token. Great. And here is a very simple Python application I wrote that essentially relies on the Redshift connector to connect to a Redshift instance and to Redshift instance and validate that everything works as expected, and that my Redshift instance is called Alteryx, and this will be my job token that I received via Postman. Once again, I'm just showing this for debugging purposes. The actual behavior in Alteryx design and the configuration will be different, but I'm just using Python to perform the test. Right, and if we have done everything correctly, we should be good to go. Let me just navigate to a folder where my Redshift application is. Okay, it's here. So I'm running Python redshift.py. And now I'm getting my list of users. Wonderful. Because the query I'm executing in this step is select all from PG user, which is basically the user base of the Redshift instance. So with this, we have successfully configured our AWS S3 and Redshift instances to work with AWS Identity Center and leverage AWS Trusted Identity Propagation to propagate Azure AD issued identities into our ADC and then obtain temporary credentials to access our respective resources, S3 and Redshift. To learn more about AWS Trusted Identity Propagation, please refer to the official AWS documentation. I should warn you that the documentation is very fractioned. So it's kind of difficult to put things to connect the dots and put things in together to make this work, which is the very reason why I'm actually recording this video. And to see how the actual configuration of this authentication method in Alteryx Designer is set, please refer to the other videos which will be supplied along with this material. Thanks a lot.